Hello, my name is Calvin with Atlas ORV, and in this video I'm going to go over a little bit more about the design process and focus in a little bit more on an area that has some issues because you have to get kind of thin to fit a larger bearing into the arm and then also fit that arm into the bearing carrier on the machine. So what I'm going to do is I'm actually going to cut the rest of this arm away and I'm going to focus just on this bit of the arm. And I've already done that, so I've done it. Again, this is 70-75, that's what we make our rods out of. And I've also done it for 60-61 to kind of show the benefits of 70-75 over 60-61. So what I did here is I made an assembly and I have the arm that I cut the end off of, and then I added a COM12 bearing, and this is hardened steel. So what I did for the finite element analysis is I said that this bearing is not going to flex. And that's a good assumption to make because it is hardened steel and it is much harder even than 70-75. So what I did was I created a fixture here, so I fixed this end of the part here so that's not going to move, and then I created a 20,000 pound load on this half of the inner part of the rod to kind of mimic what that would see when you're pulling on it, and ran that simulation. You can see a stress map here, and I'm getting a lot of good colors here. So even with 20,000 pounds of force, you can see here that I'm starting to approach into green. I got a tiny bit of yellow, maybe right about here. So I'm pretty comfortable with that. You can see my legend over here. I'm still within the yield strength of this material, which is 73,000 psi. And this is a good load that I can say I'm comfortable saying we can handle this. And then one other cool thing that I can do with FEA is I can actually show what this part would look like deformed. So I'm going to go up here and I'm going to say deformed results, and I can see where this part is going to deform. Now it's not saying this is failing, it's just when you stretch it, this is what it looks like. And this is also an exaggerated view of what it looks like. And this is here a displacement map. So red doesn't mean bad here, it just means that this is the farthest point that this thing is deformed or stretched. So that's just a cool feature, and I'll make another video about that here in a little bit, focusing on the entire rod. Alright, so now I'm going to switch over to 60-61, and I did the same exact thing. I said that this bearing is not going to flex. I created a fixture on the end and I put a force on the inner part of the arm here to mimic a pulling load. And I ran this a couple times. I was not able to pull it really past 10,000 pounds, so half of what the 70-75 rod can do. And that makes sense because 60-61 is half as strong. So here are the results for that. You can see similar amounts of green and yellow, so it matches that 70-75 rod pretty well. But again, we're only able to pull up to 10,000 pounds, and that's actually less than what the entire 70-75 rod can handle, which was 12,000 pounds, if you watch my first video on this. So I hope you learned something about FEA and being able to kind of hone in on a specific area and see what area can handle different loads. And if you have any questions, feel free to reach out, and I will see you in the next video. Thanks. Bye.